For the next part, that is learning, a definition of a particular machine learning is very important. A computer program is set to learn from experience E with respect to some class of task T and performance measure P if its performance at task is T as measured by P improves with experience E. Okay. So here what it is a computer program that learns from the experience. Okay, so here you can imagine a child in this. Why I'm telling a child is a computer is also considered as a child. When we give an input and tell the particular computer to do certain activities, then only it does those. Okay, so how the baby is taught how to pick a particular product or a particular object. Okay, what the object name is, the label of the particular object, all those things. Similarly, if we are going to train a machine, okay, giving a set of images and telling it this image is belonging to a dog, this image is belonging to a cat, this image is belonging to a particular person, then automatically when we we are going to train a particular thing, okay, then a new task is given based on the previous experience. Experience means here means we are training a particular model that becomes an experience one. Okay, experience one. Then a class respect to some class of task. Here I am going to give an image to the computer. You just consider I am going to give an image to a computer. Previously, I have given a plenty of images. In that image, I have a certain products like previously we consider an example like a fruits like banana, apple, like kind of things. The set of images you are going to give, okay, going to give to a particular model. The model get experience to find out when a new image is given. It's going to find out I have learned the things about a particular image of a fruits, okay, whether it's a banana or an apple or anything, it is only related to the fruits. Okay, based on that a performance a new task is given. New task is nothing but a new image is given. It will go to his experience that he has experienced a set of images belonging to a particular fruit. A new image is given which has a fruit. Then, based on the experience, it's going to identify whether the fruit is belonging to banana or an apple. Okay, the class, that's why the class of task T it is. Then, the performance measure P. So, after it recognizes or classify a new image as a banana, then we are going to evaluate that particular activity. Okay, that's why we call it as a performance measure. The measuring whether the new image is detected or classified as an belonging to a particular the true value or the machine is not able to recognize a particular image or not, or not able to classify it as a banana. The real image is a banana. Consider the computer has given it as a banana. We are going to see, okay, the true is banana and the machine has predicted as a banana. Then the accuracy is 100%. Okay, the true image is apple, but computer is recognizing as a banana. Then there is a false. Okay, so that is the performance measure P. If it performs at task in T, that is the task is here finding out a particular image as a fruits, one thing. In that fruits, a banana or apple, a binary classification you can call it. Okay, the performance at task in T as measured by P, the measuring performance as P Improves with experience. Improves with experience means first time I'll show as an first instances I'll show it as an banana. The computer is not able to understand it as a banana. It gives an output as an apple. That is an false. Then I'll train the system. The experience I'm going to give to improve. I'll improve the experiences. A new image is given. Okay, as an apple. Then oh, come the machine is able to detect it is an apple, then there is no problem. If a new image is given, if it misclassified, then I'm going to try. It's a continuous process. That's why improves with experience. Experience is nothing but we are going to train again and again such that we get an 100% accurate result. Okay. So learning is nothing but improving with experience at some task. Okay. So when always we are, means whenever we are going to study the things, we start learning how to solve a particular problem. Okay. How to solve a particular problem. That is consider a gaming only. You people are more familiar with different kind of games. Okay. In first round, you may succeed of getting an or winning a particular game. Okay, winning a particular game in 10 minutes. Again, same game is given, same pattern it is. You start playing it. You know previously you have gone through different angles, then you have succeeded. Similarly, with lesser amount of time, you are going to succeed. Consider in another situation, first time the new game is given to you. Okay, you start playing with it. Okay, you are not able to get an output within a certain duration, 10 minutes. Okay. So, but still you have gone through the game. Okay. You have played the game with step 1, step 2 like this. The same game is given. Then what you think is you in last experience, okay, in previous game, I have taken step 1 to step 5 in an order. I failed. So I'll what I do, I'll take step 1, step 3, step 5, and step 4 and step 2. Randomly, I'm going to change my path. So that is nothing but in each and everything, again, if you fail, again, a new approach is given. So that is nothing but improving with experience at some task. Playing a game, you fail, you start applying different logic, okay, until and unless you succeed. So whenever you fail, you are going to experience not to take up that steps, okay. So that is improve over task T with respect to performance P based on experience E. Okay. So whenever we call it as a machine learning, you need to remember these three things: TPE. T for improve over task, T is task, P for performance measure, and E for experience. Okay. So learning is nothing but improving with experience at some task. The definition of machine learning is computer program. A computer program is set to learn from experience E with respect to some class T and performance measure P if its performance at task P as measured by P improves with experience E. Okay, so that's why you keep it in a smart coding part, that is it should be TPE, task performance experience. A particular task with an experience, if you perform an activity, then the performance is measured, P is measured. Okay, so in this all those things you can see in this diagram, okay, or an image, that a person is teaching a robots, okay, robots to do a certain job. If it is not able to, you can see this particular image, how the robots are behaving. At that time, what an human is telling is, if you do it that I'll send you to the data cleaning center. Similarly, when your model behave uh, unpredictably, then you are going to see where the particular problem is and you are going to change. Okay. So here the thing is, until and unless a robot does its job perfectly with 100% accuracy, with no error, all those things, till that time you are going to train a particular robot. Okay, particular thing. The best example is learn to play checker. That is one checker game example is there. That is T is play checker. That is task is to play a checker game. P is nothing but percentage of games won in world tournament. What is the percentage of achieving all those things? Okay. Then E is the opportunity to play against self. Experience how it's going to learn. Okay. Experience is will be